Wednesday, November 5th. This is the last article that we will read for this unit, in which we've been looking at biogeography. Here we have a paper, another original research article published in Ecological Applications. This article is looking at declines of a species called the California red-legged frog, and they're using historical data to look at 4 different hypotheses. So as with most articles, they're going to give you in the background this introduction part. They're going to talk about the previous work that led to this study. They're going to talk a little bit about their data source here. And then they're going to introduce their hypotheses. What have people proposed as hypotheses for declines in the species in the past? And this is where it starts to get really interesting. They list their hypotheses that they're going to talk about here. They list 5. They actually only talk about 4. They only really test 4 because the 4 are related to biogeographic patterns that they can investigate with the data they have. Right now, I want you to get out a sheet of paper and get ready, because what you're going to do is you're going to take notes on the predictions for each of these 4 hypotheses. There are predictions for changes in population presence or absence according to altitude, according to latitude, according to temperature, according to relationship with agricultural or urban sites. And so you want to have that prediction written down for each and every one of these 4 hypotheses. You must come into class with those written down to be able to complete your team activity. Don't let your team down, have that done. So they start right here with the global warming and UVB hypotheses. They mainly focus on global warming here, then UVB. Then they go into the pesticide or chemical hypothesis, and then habitat destruction here. So this is the section. This page right here is going to give you the answers that you need to figure out what the predictions are that they'll be looking at for each hypothesis. Okay, a couple other notes here for this article. They talk in their materials and methods about a series of assumptions that they have made. I will point out a couple here. I would suggest that you also make a list of the assumptions they've made and how their effect will be evaluated and how their effect is justified. So, for example, of course they tell you their source of data here, which is great, their historical sites. They say that they restrict their analysis to historical observation or historic locations, right? And they set this time frame as pre-1975 is historic, and then they justify that by talking about decline starting in the 1970s. So you want to ask yourself, right, why 1975? And then when they start talking about the 1970s, you want to say, is this answer good enough? They also talk about sites that they excluded from their study. So look for those somewhere down here. I don't have it marked. They also talk about expert opinion up here. So in this paragraph up here, so what does that mean? They talk about a couple more assumptions they make down here, so make notes on those. Okay, continuing a little more on assumptions here in this section here. And then they talk about how to separate out land use from pesticides, right? They have 2 different hypotheses, one on pesticides and one on just straight up land use, agriculture, urban, and that kind of thing. So how do they separate those out? I had an interesting question as I was reading through here when they're talking about wind-blown pesticides, right, negatively affecting frogs. How else could you follow up to see if wind-blown pesticides are negatively affecting frogs? Maybe something that isn't using historical data, or maybe something that is using historical specimens. I think that think about ways that you could do that, especially as you're thinking about your own projects. I'm sure that will come to mind here. They describe a little bit their statistical analyses. in this section here, they start talking about building a model with all the variables in it and then removing them one by one. Why are they trying to remove variables? Well, they're trying to come up with the model that is the simplest. There's something called Occam's razor, which says that the simplest model that makes the fewest assumptions, that's the model that is preferable when you are trying to explain an observed effect. So that's what they're trying to do here, is get to the simplest model. Throw out any variables that are not having a strong or significant effect. So that's just what they're talking about here when they're explaining what they did for their statistical analyses. Okay. Then they're going to start talking about how they validated their data with a separate data set. So really good thing to do to validate your data. And then they talk a little more about, validating these concerns that they had, right? These assumptions they made about expert opinion, for instance. And then they do a sensitivity analysis to figure out if these assumptions are making a difference in their results, including independence of sites. And basically, they just went through here and they're justifying all their analyses and they're justifying the data that they use. Why are they doing that? So I'm going to take you back to the first page right now and give you an idea about why they might be doing that. So when they submitted their paper, they submitted their manuscript in August of 1999, and then you notice that they revised it in February and then resubmitted it. And it was accepted then in February, right, the day afterward. So what happens is they submitted it, they got several reviewers, probably about 3 reviewers. Those reviewers looked at it, and they probably brought up a bunch of these concerns and said, okay, you need to think about this expert opinion. Look and see how it affected things. You need to think about independent sites. If your sites are very close together, are they really an independent evaluation of all of these considerations, or are they just pseudo-replicates, basically? And so they went back and they probably did some more analyses, or they had, if they were really good, they'd already done those analyses, and then they just added the text in to say, oh, this isn't an issue. We looked at it, and this is how we know it's not an issue. So that's what's going on there. And one reason they're going to really need to justify that expert opinion is because 53% of that data comes from expert opinion. So that's a lot. Okay, now they're really getting into declines here, okay, or results here. So what are they finding? What's the pattern of decline? And so I made, just a list of what did I see as the pattern of decline? Right, the declines were at higher elevations, with a higher percent of upwind agriculture and a higher percent of urban sites and lower latitudes and so on. I just made a list of what did they find for results as I was reading through the text. And then, as usual, I got a little bored with that and I started to look at the figures, because the figures are really what's going to tell you what's happening. So I wanted to get familiar with their field sites, right? They have these different regions: SoCal, Central Valley, Sierra, then they have Central Coast. So 3 main regions. And then they show you with symbols what they found. So absent frogs are in triangles, and present frogs are in circles. And then they show you where agriculture is, these colored in areas, and then they show you the wind patterns with arrows. This figure takes a while to interpret, so take a little bit of time to look at the difference between circles and triangles and look at those directions of arrows. So the wind is going from here, from this agricultural area, up through here, right? Over here. From here over here, right? So you're seeing direction of wind. Then I started looking at table 1 and highlight, of course, anything that's significant right here. And actually, I think it's probably easier to highlight the stuff that's not significant, right? So this is a p-value that's not significant. These are 2 p-values that are not significant. Otherwise, basically, just about everything else is significant. Here's another one down here that's not significant. So you can use that to annotate what is this table telling you. So this is just a nice table of results. Okay, now we go over, keep reading, right? We've got another figure So when I'm looking at the p-values, of course, to see, okay, this one is significant, this is significant, this is significant, this one's not, so I'm not going to really look at urban. I'm going to note that that's not significant, and this is also not significant, so this is another one that isn't a significant relationship. So tell yourself, what does this mean? Okay, for example, elevation here. The percentage of sites where frogs went extinct, right? More extinct sites with increasing elevation. Which hypothesis does that support? Okay, latitude, you don't see a good pattern here, right? Southern and northern sites at the extreme ends had more extinctions. So we don't see a gradient from increasing or decreasing with latitude. And same thing go throughout here. For each little box, which hypothesis does this support? This is something we're going to pick up on again in class, so really pay attention to that. I think the last main thing I'm going to talk about here is explaining this logistic regression model for people who might not be familiar with this. Okay, so these variables on the left side, right? Latitude, elevation, percentage of upwind agriculture, percentage of urban spaces nearby. These are your predictors. These are the variables. And then your response is the number of frogs, and it sort of tells you down here the dependent variable is frogs present or absent, right? So you're looking for the relationship, right? And you're looking for significance. So first thing I always do is I go down and I cross off anything that is not significant. Okay, and it turns out if you're looking for the 0.05, this is the only one that wasn't significant. So I just crossed that off right away. Then I went to look at this regression coefficient, this B here. Okay, so this tells you the direction of the relationship. So you have, well, let me explain a little bit. So the regression coefficient, what this is this says the mean change in the response variable, or the dependent variable, which is the number of frogs, for every 1 unit of change in your predictor variable if all the other predictors are held constant. This is important because it isolates the role of one predictor. So what happens with latitude, for instance, when everything else is held constant? Okay, so increasing latitude increases number of frogs. So more frogs present when latitude is higher. This is a positive relationship. Negative relationship for elevation. So increasing elevation means fewer frogs, or decreasing elevation means more frogs, right? This negative relationship, okay? And you can go down through each of these and see what those relationships were, right? The direction of the relationship and their significance. But what I also want to point out here is that they had an effect of region on their model. So they looked at if they left region and didn't account for it, if they accounted for regions, if they ran the model just on particular regions, what was significant within region. Those different regions in California are very different. They have very different characteristics, and so that was one way of getting at the effect of region, or actually taking out the effect of region. Okay. So let's see if I have any other notes for you on these other tables here. So this table 3, I want you to think about for which variables are the means different in present versus absent sites, right? So you have present sites here, absent sites here, and then the mean, right, is what's showing in this table. So for instance, mean elevation for sites where frogs were absent was 476, whereas mean elevation for sites where frogs were present is 239. So that is, it doesn't tell you significance here, but that is a significant difference. It gives you the plus or minus, right, so you can figure out if it's significant or not by adding that or subtracting it. So look through this, circle anything that is significant. What stands out to you? I have a wow written down for one of these things. Also look at the number of sites that had presence and absence, right? Central Coast here only had 11 sites where they were absent, whereas the others had many more sites with absences, okay? Okay, now they're going to get into robustness analysis. They're going to explain where they